Okay, relations and functions, Unit 5, Day 1. So let's just get right into this. A relation is a set of ordered pairs. So there's different ways of representing relations. You can do it in a table where you have your x values and you have y values. So like when x is 5, y is negative 3. When x is 6, y is 2. When x is 7, y is 0, and so on. You can map it. So when x is negative 5, y is 0, and so on. You can graph it, so you just have points on a graph, or you can do it by an equation. So like y equals negative 3x squared plus 7. So there's 4 different ways of representing these. Okay? Domain is the set of x values. Range is the set of y values. So domain is right to left, range is up and down. Domain is your x values, range is your y values. Super important to remember that. Okay, so let's give the domain and range of each of the following relations. So remember, domain is x values, range is y values. So in the first example, my x values are negative 1, 7, 3, and negative 5. My y values are negative 1, 4, 0, and negative 1 again. So my domain, I'm just going to put it in the little squiggly brackets from least to greatest. So it's negative 5, negative 1, 3, and 7. The range is negative 1, 0, and 4. Okay? Let's look at example B. So I'm just going to write all those points out. So like that point on the bottom left is negative 3, negative 4. And then there's negative 1, positive 5, 1, 2, 1 and negative 3, and 2, 0. So I have all my values. Then I'm just going to write my domain. So my domain is negative 3, negative 1, 1, and 2. Because those are all of the x values. My range is negative 4, negative 3, 0, 2, and 5. Okay? Let's look at this last one. So domain again is x values, range is y values. So my domain here is negative 2, negative 1, 0, 1, and 2. My range is 0, 1, and 4. Okay? Pretty straightforward. Just remember, domain is x values, range is y values. Okay, now it says to give the domain and range in set notation. So set notation is you have the squiggly bracket and it's x such that, so the line, and then you put like x is greater than 0, or all real numbers, or x cannot equal this certain number. Okay, so let's look at example A. Domain, that graph is going to go forever left. Like it's going to just continue to increase. It looks like it's going down, but it's going to continue to go in the left direction. And it's going to continue forever right. So my domain here is all real numbers. And when it's all real numbers, you can just put that little r. It's usually, I wasn't sure if that's the right r. When you write it, that's how I usually write it. Just the 2 lines and then an r. Okay? So the domain is all real numbers. The range is y is less than 6. So it's a squiggly bracket, all y, such that y is less than or equal to 6. Because 6 is the highest point that it ever touches right there. Okay. Now let's go to example B. So my domain here, the furthest left this goes is negative 3. So it's all x, the set of all x, such that x is greater than or equal to negative 3. Because that's the least value it equals. Okay? We look at our y's. The smallest y value is negative 4. So it's y such that y is greater than or equal to negative 4. Okay? Let's look at example C. So the domain, it's going to go forever left and forever right, but there is a value it doesn't equal. It does not equal positive 3. So it's all x such that x does not equal positive 3 because there's an asymptote right there. So it never equals negative 3. And the range is all y such that y does not equal 0 because there's also an asymptote right there. Y will never cross that axis. Okay? Now we have to give it an interval notation. I think you guys are a little bit more familiar with interval notation. So that's when you just put, so the bracket means it's included, and then the parenthesis means it's not included. So let's look at example A. The domain, that's going to go forever left, is going to go forever right. So that's going to be from negative infinity to positive infinity. And those are both parentheses because you can always find another number smaller than whatever number you're at. So infinity, you can never actually equal infinity because you can always find another number. So that's why those are parentheses. Okay? The range here, the furthest down it goes is -5. The furthest up it goes is +5. And it equals -5 and it equals +5. So those are brackets. Okay? Let's look at B. It looks like there's a hole there at -1 when x equals -1. So the domain is going to be negative infinity to -1. Then the u, that's a union, so that means and pretty much, and -1 to infinity. So that's my domain right there. And you have to put that u in there. The range is negative infinity to -3, and then the union, -3 to infinity. Okay? Let's look at this last one. So the domain here is -4, and it does not equal -4 because that's an open circle there, to +1, and it does equal +1 because it's a closed circle there. The range is -7, and it does equal -7 up to +2, and it does equal +2, and there's values all in between there, so those are both brackets. Cool? Okay. This is kind of long. You have to bear with me. We have to get through it, though. So a function is a special type of relation. I don't know what just happened. So a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. So that means for each x value, there is just one y value. Okay? So if we look at example A, -9 goes to -2 and to +5. So that one is not a function because -9 has 2 y values and we only want one y value. Okay, so that one doesn't work. B is a function because each x value has only one y value. And C is also a function because each x value has only one y value. Y values can have more than one x value, but x values can only have one y value. Okay? A way to test this, if you're given a graph, is the vertical line test. If it crosses only one time, it is a function. If it crosses 2 times, it is not a function. So if we look at A, we draw that vertical line. It only crosses once. That is a function. Look at B, vertical line, that crosses twice. So that is not a function. Okay, C, right there it only crosses once. I'm going to double check this other side of the graph also. Right there it also only crosses once. So that is a function. Okay? Now, equation and function notation. You guys should know function notation. We've done it. We're just going to go through it. So an equation is y equals 3x squared minus 5. That in function notation is f of x equals 3x squared minus 5. And that's read as f of x. Okay? And it's interpreted as the value of the function f at x. So the function is in terms of x. Okay? So if we're asked to evaluate a function, like let's look at A. We're asked to evaluate that, so I'm just going to plug -5 in for all of my x's. So that's -5 squared minus 6 times -5 plus 23, which is 25 plus 30 plus 23, which equals 78. You could also just plug that parentheses -5 squared minus 6 parentheses -5 plus 23 into your calculator and you'll get 78 also. Okay? Let's look at example D. So I'm going to plug in -10 for that. So that's the absolute value of 1/2 times -10 minus 14. 1/2 times -10 is -5 minus 14. -5 minus 14 is -19. but the absolute value of negative 19 is positive 19. So P of negative 10 equals positive 19. Okay, let's do example E. So if we need to evaluate at 3y squared, I'm going to plug 3y squared in for my x's. So I have 3y squared cubed plus 3y squared squared. So if you do 3y squared cubed, that's 3 cubed and y squared cubed. 3y squared squared is 3 squared and y squared squared. So that becomes 27 y to the 6th plus 9 y to the 4th. And you're done with that one. Okay, so that you just you plug it in and then you just start simplifying it down. Let's also look at G. So if we have h of 2a plus 7, I'm going to plug 2a plus 7 in for all my x's. And then I'm just going to start multiplying this out. 2a plus 7 squared is the same thing as 2a plus 7 times 2a plus 7. Then that's minus 2a plus 7 minus 1. 2a plus 7 times 2a plus 7 is 4a squared plus 14a plus 14a plus 49. I'm going to distribute that negative in for the minus 2a plus 7. So that's minus 2a minus 7 minus 1. Then I just finish with combining like terms. So that's 4a squared. 14a plus 14a is 28a minus 2a is 26a. And then 49 minus 7 is 42 minus 1 is 41. And that's your final answer there. Okay, so evaluating is pretty simple. You just plug in what they give you for your x's, and then you just have to go through and simplify it. Okay? Let's look at this one. So if you're given a graph and asked to find the value of the function. So we're asked to find f of 1. So I'm going to go to 1 on my x-axis. Okay? 1 is right there. Now, so f of 1, I'm going to go down to that point, and that equals negative 9. So f of 1 equals negative 9. I'm going to do the same thing for negative 2. So I'm going to go to negative 2, plug that in. So f of negative 2 equals 0, so it's right there. Ignore Brittany Coleman. Sorry. We have many questions. Okay. F of 5 is 6. F of 0 is negative 8. Okay. Now let's go to x and y intercepts. Sorry, this is so long. I'm trying so hard to get through it fast. Okay. So the intercepts are points where a graph intersects the x or the y axis. The x-intercepts occur where y equals 0, and the y-intercepts occur where x equals 0. And a function can have 0 or multiple x-intercepts, but at most one y-intercept. So you can only cross the y-intercept once, but you can cross the x-axis as many times as you want. Okay, so let's look at number 1, or example G. So that crosses the x-axis right there, which is at 4, 0. So that's my x-intercept. That crosses the y-axis right there at 0, 2. So that's my y-intercept. Now let's look at H. That crosses the x-axis at negative 1, 0, 1, 0, 2, 0, and 3, 0. So it crosses there 4 times. It crosses the y-axis only 1 time, and that's at 0, 5. Okay? Here, we never cross the x-intercept, so there's no x-intercepts. Or the x-axis, so there's no x-intercepts. The y-intercept, we do cross 1 time, and that is again at 0, 5. Okay? So, sorry, to find zeros algebraically, you set f of x equal to 0 and solve for x, and then to find the y-intercept, you find f of 0. So let's just do example A. Maybe. Come on. So we have f of x equals negative absolute value of x minus 5 plus 3. So to find the zeros, I'm going to set f of x equal to 0 and solve for x. So that's going to be 0 equals negative absolute value of x minus 5 plus 3. I'm going to subtract that 3 over, and I'm going to divide by negative 1. So I have 3 equals the absolute value of x minus 5. Now remember, absolute value, you always set equal to the positive and to the negative. So I have x minus 5 equals 3, x minus 5 equals negative 3, which means x equals 8 and x equals 2. So those are my zeros. So my zeros are 2, 0, and 8, 0. Now for my y-intercept, I'm going to have f of 0, and I'm just going to evaluate that. So that's the negative absolute value of 0 minus 5 plus 3, which is the negative absolute value of negative 5 plus 3. The absolute value of negative 5 is positive 5, so negative 5 plus 3 is negative 2. So my y-intercept is 0, negative 2. Okay? Let's do this one. Now, to find my zeros, I set f of x equal to 0, and I'm going to factor this. So when you factor this, that's x to the 4th, and then 5x squared and 4. If that was x squared and 5x and 4, you could factor just using the x. So we're going to do the same thing here. And so that will factor down to x squared minus 4 and x squared minus 1. Because you just take half of the x to the 4th, which would be x squared. So instead of putting x's in there, you put x to the 4th in there. Now, x squared minus 4 factors down to x plus 2 and x minus 2. X squared minus 1 factors down to x minus 1, x plus 1. And then you just solve it. So x equals 2, negative 2, 1, and negative 1. So my zeros here are negative 2, 0, negative 1, 0, 1, 0, and 2, 0. Okay? Then to find my y-intercept, I'm going to evaluate f of 0. So that's 0 to the 4th minus 5 times 0 squared plus 4, which just equals 4. So my y-intercept is 0, 4. Okay? There are the answers to the rest of those if you want to do them. And then please remember to take the quiz, and I will see you guys next time.